This section will provide a short introduction to hydraulic graphical symbols. Graphical diagrams of hydraulic systems do not show actual size, shape, location, or construction of any component. They illustrate function and connections. The basic symbol for a valve is a square. Arrows are added to the square to show flow paths. Infinite position pressure and flow control valves have only one square. They are able to take any position between fully open and fully closed. Finite position valves are directional valves. These symbols contain a square for each position the valve can be shifted to. A circle is the basic symbol for rotating components. Triangles are placed in the symbol to show if they are energy receivers, motor, or sources, pump. If the triangle is pointing out of the circle, it is a pump. If the triangle is pointing into the circle, it is a motor. A reversible motor or pump is drawn with two triangles. A cylinder is shown as a rectangle. The piston, piston rod, and port connections are also shown. Click on the hotspots to see the symbols. This section will provide a short introduction to direction control valves and their construction and operation. The direction control valves can start, stop, and control the direction of flow. They are classified according to principal characteristics such as type of internal spool, methods of actuation, number of flow paths, size, connections. A basic direction control valve consists of body, spool, spring, lever, This valve has three positions of operation. It can raise, hold, or lower the load. A box represents each position. Inside the box are two arrows, each representing a direction in which oil can flow. Left box, connection from PA and BT. Mid box, all connections closed. Right box, connection from PB and AT. In the drawing shown here, the spool is in mid position and all ports are closed. In the drawing shown here, the valve is actuated so there is connection between P and A and T and B. In the drawing shown here, the valve is actuated so there is connection between P and B and T and A. There will always be a small internal leak in the direction control valve. This leak is dependent upon the gap between the spool and the body, the length of this gap, the viscosity of the oil, the pressure difference between the connections. A rotary valve consists of a rotating spool that is fitted into a body. Passages in the spool connect or block the ports in the valve body. The graphic symbol for a rotary valve is the same as for a sliding spool valve. A check valve is a one-way directional valve. It allows free flow in one direction while blocking flow in the other direction. In the free flow direction, the valve opens at a pressure equivalent to the spring force. In the no-flow direction, the fluid will press on the ball and close the valve. There will always be a pressure drop through the valve, and if the flow through the valve increases, the pressure drop through the valve also increases. This valve acts like a conventional non-return valve, but can be opened by pilot pressure to allow flow in the reverse direction. They are virtually leak-free when closed and are thus useful in preventing creeping or inadvertent movement of an actuator. They may also be used to prevent movement of an actuator if a hose or a pipe bursts. This section will provide a short introduction to hydraulic actuators, their construction and operation. A hydraulic actuator is a device for converting hydraulic energy into mechanical energy. The type of job being done and its power requirements determine the correct type and size of actuator. Cylinders are linear actuators. The output of a cylinder is a straight-line motion and force. Cushioning, or end positioning, refers to the braking and deceleration of the piston as it reaches the end of its stroke. Cushioning becomes essential above a piston speed of 0.1 meters per second. Here you will see an example of the end cushioning mechanism at the cap end. The cushioning of the rod end is similar. The piston is fitted with a tapered cushioning plunger. When this plunger enters into the bore of the end cap during the final part of the stroke, the fluid exit is gradually closed. This first stage of exit throttling causes an initial speed reduction. The remaining fluid now escapes through the needle valve. The degree of cushioning and the second stage speed control is adjusted with this valve. The check valve is fitted to ensure a fast and full force breakaway from the end position. Hydraulic motors is the name given to rotary actuators. There are several different types of hydraulic motors. Unidirectional fixed displacement, bidirectional fixed displacement, unidirectional variable displacement, bidirectional variable displacement. Semi-rotary motor. The popular belief is that a hydraulic motor is nothing but a hydraulic pump run backwards, but there are many differences in operating demands between pumps and motors. Motors closely resemble pumps in construction. In the piston pump, instead of the pistons pushing on the fluid drives the pistons, developing torque-creating motion. This also occurs in the vane-type motor. Hydraulic motors are rated according to displacement, size, torque, capacity, speed, and maximum pressure limitations. Semi-rotary motors are partial rotation output devices, which usually cannot rotate continuously in one direction. They are normally limited to something less than a full revolution. Most semi-rotary motors are of the single or double vane type. They are capable of very high torque.